Building an artificial intelligence chatbot, similar to the well-known ChatGPT, might seem like a task reserved only for giant tech companies with unlimited resources. However, the reality is that creating your own AI is more accessible today than ever before. There are two main roads you can take on this journey. The first path is a simpler, more direct route that involves using existing technology. The second path is far more challenging and involves creating a new language model from the very beginning. Each approach has its own set of requirements, costs, and benefits, making one far more suitable for most individuals and small businesses than the other. This guide will walk you through both of these methods in a clear and straightforward way. We will explore the step-by-step process for each option, helping you understand what is involved. The first option, using an application programming interface, or API, is like renting a powerful engine for your car. You don't build the engine yourself, but you can install it and customize it to fit your specific needs. This makes it a popular choice for developers and businesses who want to create powerful applications without the massive upfront investment. It allows for rapid development and deployment. On the other hand, the second option, training a model from scratch, is like designing and building that powerful engine yourself. This process demands deep expertise, enormous amounts of data, and significant computational power. It is a journey that requires a dedicated team of experts, including data scientists and machine learning engineers. While it offers the ultimate level of customization and control, it is often prohibitively expensive and time-consuming for anyone outside of major research institutions or technology corporations. This path is for those who have a very specific, novel use case that existing models cannot fulfill. Understanding the difference between these two paths is the first and most crucial step in your AI development journey. Your choice will determine your budget, your timeline, and the skills you will need to succeed. For most people, the goal is not to reinvent the wheel, but to use the amazing wheels that have already been built to create something new and useful. This essay will provide you with the knowledge to make an informed decision, ensuring you select the path that best aligns with your goals, resources, and technical capabilities, setting you up for a successful project. The most common and practical way to build a chatbot like ChatGPT is by using a pre-trained large language model through an API. An API, or Application Programming Interface, is essentially a bridge that allows your application to communicate with a powerful, existing AI model hosted by a company like OpenAI, Google, or Anthropic. Instead of building the complex core of the AI yourself, you're essentially renting its intelligence. This method dramatically lowers the barrier to entry, making sophisticated AI accessible to developers, startups, and even hobbyists who have a great idea but lack the resources to build a language model from the ground up. The process of using an API is designed to be user-friendly and efficient. You start by signing up for an account with an AI provider and getting an API key, which is like a secret password that grants your application access to their model. Once you have this key, you can send requests to the AI. For example, you can send a user's question to the model and receive a generated answer back in a matter of seconds. This interaction is the foundation of your chatbot. The heavy lifting, the complex computations and data processing, is all handled on the provider's powerful servers. The primary advantage of this approach is the immense savings in time, money, and expertise. Training a large language model from scratch can cost millions of dollars in computing power and requires a team of specialized engineers. By using an API, you pay a small fee based on your usage, often just fractions of a cent per request. This pay-as-you-go model allows you to scale your application without a massive initial investment. You get immediate access to a state-of-the-art model that has been trained on a vast and diverse dataset, ensuring it can handle a wide range of topics and questions. Furthermore, these API providers handle all the maintenance, updates, and improvements to the underlying model. As the AI technology evolves and the models become more capable, your application automatically benefits from these advancements without you needing to do any additional work. This means you can focus on what makes your application unique: its user interface, its specific purpose, and the curated data you use to fine-tune its responses. It frees you to concentrate on the user experience rather than the complex infrastructure required to run a massive AI. This is why the API route is the standard for nearly all chatbot applications today. Before you write a single line of code or make your first API call, the most critical step is to clearly define the purpose of your chatbot. What specific problem will it solve? Who are your target users? A chatbot designed for a hospital to answer patient questions about visiting hours will have a very different role than one created for a gaming website to provide tips and lore. Defining its purpose helps you set clear boundaries for what the chatbot should and should not do. This foundational step guides every subsequent decision, from the data you use to the tone of its voice. Is it a customer service agent, a creative writing partner, or maybe a personal tutor? Once the purpose is established, you need to shape its personality. The personality of a chatbot is crucial for user engagement and creating a positive experience. Do you want it to be formal and professional, like a corporate assistant? Or should it be friendly, witty, and informal, like a companion or entertainment bot? This personality should be reflected in its language, tone, and even its name. For example, a banking chatbot should be reassuring, precise, and trustworthy. In contrast, a chatbot for a children's educational app might be encouraging, playful, and patient. A well-defined personality makes the interaction feel more natural and less robotic. This definition phase involves creating a set of guidelines or a constitution for your AI. This document should outline its core mission, its intended audience, its personality traits, and any specific rules it must follow. For instance, you might specify that the chatbot should never offer medical or financial advice, or that it must always disclose that it is an AI. These instructions, often called system prompts or pre-prompts, are given to the language model before it interacts with any user. They act as a permanent set of instructions that steer the AI's behavior and keep it on track with its designated role. Finally, consider the scope of its knowledge. A general-purpose chatbot tries to answer everything, but a specialized bot is often more useful. If you are building a customer service bot for an online shoe store, its primary goal is to know everything about shoes, shipping, and returns. It does not need to know about astrophysics or culinary arts. Limiting its scope not only makes the chatbot more effective at its job, but also helps manage user expectations. Clearly communicating what your chatbot can do at the beginning of an interaction prevents user frustration and leads to a more successful and helpful tool. After defining your chatbot's purpose, the next step is to choose the right AI platform and model. Major providers like OpenAI with its GPT models, Google with Gemini, and Anthropic with Claude all offer powerful APIs. Your choice may depend on factors like cost, performance, specific features, and ease of use. Some models might be better at creative tasks, while others excel at factual recall or logical reasoning. It's a good idea to experiment with a few different options to see which one best aligns with the personality and tasks you have outlined for your chatbot. Most platforms offer free credits to get you started. Once you have selected a platform, you can begin the process of customizing the pre-trained model to better suit your specific needs. This is often done through a technique called fine-tuning. Fine-tuning involves providing the model with a custom data set of examples that are highly relevant to your chatbot's purpose. For a customer service bot, this dataset might consist of hundreds or thousands of question and answer pairs specific to your company's products, policies, and common customer issues. This process doesn't retrain the entire model, but rather adjusts its existing knowledge to become an expert in your particular domain. Creating this dataset is a crucial part of the process. The quality of your fine-tuning data directly impacts the quality of your chatbot's responses. The data should be clean, accurate, and consistent with the desired tone and personality. For example, if you want your bot to be friendly and casual, all the example answers in your dataset should reflect that style. You can create this data manually, extract it from existing company documents like FAQs and support logs, or use a combination of methods. The more high-quality specific examples you provide, the more reliable and accurate your chatbot will become. Beyond fine-tuning, you can also implement a technique called Retrieval Augmented Generation, or RAG. With RAG, instead of trying to bake all knowledge into the model itself, you give the chatbot access to a separate, up-to-date knowledge base, like your company's internal documents or product database. When a user asks a question, the system first retrieves the most relevant information from this knowledge base and then feeds it to the language model along with the user's query. This allows the chatbot to provide answers based on real-time, accurate information, which is especially useful for information that changes frequently. With your AI model chosen and fine-tuned, the next stage is to build a user interface, or UI, where people can actually interact with your chatbot. The UI is really the bridge between your user and the powerful AI model working behind the scenes. This can be as simple as a chat window on a website, a feature within a mobile application, or even an integration into a messaging platform like Slack or Facebook Messenger. The goal here is to create an intuitive and seamless experience. The design should be clean, making it easy for users to type their questions and read the responses. A good UI makes the technology feel accessible and friendly. Developing the UI involves front-end development work to create the visual components and back-end development to handle the communication with the AI's API. So when a user types a message and hits send, the front-end captures that message. The back-end then takes that message, formats it correctly, and sends it to the language model's API, along with your secret API key. The API processes the request and sends the AI's response back to your server. Your back-end code then forwards this response to the UI, where it is displayed to the user. This entire round-trip process should happen as quickly as possible to ensure a smooth conversation. Thorough testing is an absolutely essential part of this stage. Before you release your chatbot to the public, you need to test it extensively to find and fix any problems. This includes testing its accuracy, its tone, and its ability to handle unexpected or unusual questions. You should have a group of test users interact with the bot and provide feedback. Are its answers helpful? Does it ever give incorrect or nonsensical information? Does it stick to its defined personality and rules? This testing phase helps you identify weaknesses and edge cases that you can address by refining your system prompts or improving your fine-tuning data. Finally, after initial testing, you should plan for a gradual rollout and continuous monitoring. You might start with a beta launch, making the chatbot available to a small group of real users. During this time, it is important to collect data on the conversations, while respecting user privacy, to see how the chatbot is performing in the real world. Monitoring these interactions will reveal common user questions and any areas where the chatbot is struggling. This feedback loop is vital for ongoing improvement, allowing you to continually update and refine your chatbot to make it more helpful and reliable over time. Section 6. Option 2. The complex path of training from scratch. While using an API is the practical choice for most, there is a second, far more arduous path: training your own large language model from scratch. This approach is fundamentally different because you are not just using an existing AI, you are creating the core intelligence itself. This journey is akin to building a car factory from the ground up instead of just buying a car. It involves designing the model's architecture, which is the complex mathematical structure that allows it to learn from data. This requires a deep understanding of advanced mathematics, neural networks, and machine learning engineering. The primary reason a company might choose this path is to create a model that is uniquely tailored to a highly specific, proprietary, or sensitive domain where existing models fall short. For example, a legal firm might want to train a model exclusively on its decades of internal case files and legal documents to create a specialized research assistant. Similarly, a biomedical research company might train a model on a massive corpus of scientific papers and genetic data. In these cases, the goal is to build an AI with unparalleled expertise in a narrow field, a level of specialization that a general-purpose model cannot achieve. However, the resource requirements for this path are astronomical. First, you need an enormous amount of computational power. Training a large language model requires hundreds or even thousands of high-end GPUs running continuously for weeks or months. The cost of this hardware and the electricity to run it can easily run into the millions of dollars. This is why such projects are almost exclusively undertaken by tech giants like Google, Meta, and Microsoft, or by well-funded research labs that have access to supercomputing clusters. Beyond the hardware, this endeavor requires a world-class team of experts. You need data scientists to collect and prepare the data, machine learning researchers to design the model architecture and training algorithms, and software engineers to build the complex infrastructure to manage the entire process. Hiring and retaining this level of talent is incredibly expensive and competitive. For these reasons, training a model from scratch is not a feasible option for individuals, small businesses, or even most large companies. It remains a frontier of AI research, not a practical solution for everyday applications. Section 7. Step 1. Gathering and preparing a massive dataset. The first and most formidable challenge in training a language model from scratch is acquiring and preparing the data. A large language model's intelligence comes directly from the data it is trained on, and it needs a colossal amount. We are not talking about thousands of documents, but rather a dataset that encompasses a significant portion of the entire internet. The training corpora for models like GPT-3 include trillions of words, sourced from books, articles, websites, and scientific papers. Gathering such a vast quantity of text is a monumental undertaking in itself, involving web scraping on an industrial scale. Once you have gathered this raw data, the real work of cleaning and pre-processing begins. The internet is filled with low-quality content, duplicate pages, formatting errors, personal information, and toxic language. All of this noise must be meticulously filtered out. A model trained on messy, unfiltered data will produce messy, unreliable, and potentially harmful outputs. The data cleaning process involves writing complex scripts and algorithms to remove duplicates, correct formatting, and filter out inappropriate content. This stage requires careful judgment and a huge amount of computational effort to process petabytes of raw text. Furthermore, you must ensure the dataset is diverse and representative. If your training data is biased, your model will be biased. For example, if the data primarily comes from one demographic or cultural perspective, the model's responses will reflect that narrow worldview. Building a balanced dataset means actively seeking out and including text from a wide variety of sources, genres, and viewpoints. This is not only an ethical necessity to ensure fairness, but also a technical one to create a model that is broadly capable and useful to a wide range of users. It is a significant and ongoing challenge in the field of AI development. Finally, all of this cleaned data must be tokenized. Tokenization is the process of breaking down the text into smaller pieces, like words or subwords, that the model can understand as numerical inputs. This might sound simple, but developing an efficient vocabulary and tokenization strategy is a technical challenge in its own right. The quality of this entire data preparation pipeline, from collection and cleaning to tokenization, is arguably the single most important factor determining the final performance of the trained model. A flawed dataset will inevitably lead to a flawed AI, no matter how sophisticated the model's architecture is. Section 8. Step 2. The demanding process of training and deployment. After preparing the massive dataset, the training process begins. This is where the model learns the patterns, grammar, context, and knowledge embedded in the text. The model, which starts as a vast network of random numbers, is repeatedly shown batches of data. With each batch, it tries to predict the next word in a sentence. It then compares its prediction to the actual next word and calculates an error. This error is used to make tiny adjustments to the millions or billions of parameters within its neural network. This process is repeated trillions of times, gradually making the model's predictions more and more accurate. This training process is incredibly computationally intensive. It requires a distributed computing infrastructure, where the task is split across hundreds or thousands of powerful GPUs working in parallel. A single training run can last for several weeks or even months, consuming a tremendous amount of electricity. During this time, engineers must constantly monitor the process, watching for signs of instability or slow progress. They may need to adjust hyperparameters, which are the settings that control the learning process itself, such as the learning rate. It is a delicate balancing act that combines science, engineering, and a bit of artistry. Once the initial training is complete, the model is not yet ready for public use. It must undergo further stages of refinement, including fine-tuning and alignment. Alignment is a critical step to make the model helpful, harmless, and honest. This often involves a technique called reinforcement learning from human feedback, RLHF. In this stage, human reviewers rate the model's responses to various prompts, creating a dataset of preferences. The model is then further trained to produce responses that align with these human preferences, steering it away from generating harmful, biased, or untruthful content. This is what helps make the model a safe and useful assistant. Finally, after all the training and alignment, the model must be deployed for use. This involves a process called inference, where the trained model generates responses to new prompts. Even running a fully trained model requires significant computing resources. To serve millions of users, companies must build and maintain a robust, scalable infrastructure of servers to handle the constant flow of requests. The model must be optimized for speed to ensure users receive answers quickly. This entire lifecycle, from data collection to deployment and ongoing maintenance, is a continuous, expensive, and highly complex operation. Section 9. Conclusion. Choosing the right path for your project. We have explored the two distinct paths to creating an AI chatbot: the accessible route of using a pre-trained model via an API, and the formidable journey of training a model from scratch. The first option empowers nearly anyone with a good idea to build a sophisticated chatbot. By leveraging the power of existing models from companies like OpenAI or Google, you can focus on what makes your application unique: its purpose, its personality, and the specific data you use to customize it. This approach is cost-effective, fast, and requires far less technical expertise, making it the ideal choice for the vast majority of projects. This API-driven method is behind the explosion of AI tools we see today, from customer service bots that provide instant support on websites to creative assistants that help writers, artists, and programmers. By following the clear steps of defining your purpose, choosing a platform, fine-tuning with your data, and building a user-friendly interface, you can create a powerful and valuable application. You benefit from the billions of dollars of research and development that have already been invested in these foundational models, allowing you to stand on the shoulders of giants and build something amazing without starting from zero. In stark contrast, training a language model from the ground up is a monumental endeavor reserved for a select few with immense resources. The requirements: a massive, clean dataset, millions of dollars in computing power, and a team of world-class AI researchers place this option out of reach for almost everyone. It is a path for those pushing the absolute boundaries of AI science, or those with such a unique and proprietary need that no existing model will suffice. It is a high-risk, high-cost venture that aims to create a fundamentally new piece of technology, not just a new application. For anyone looking to build their own chatbot, the recommendation is clear: start with an API. This path offers a low-risk, high-reward entry into the world of AI development. It allows you to experiment, learn, and build a functional and useful product quickly and affordably. The power of modern AI is no longer locked away in research labs. It is available to you through a simple programming interface. By making the pragmatic choice, you can harness this incredible technology to solve real-world problems and bring your innovative ideas to life.